In this video, we're going to solve an equation using factoring and the zero product principle. The particular equation that we're asked to solve is x cubed minus 4x squared minus 9x plus 36 equals 0. The first thing that we want to note as we write that left-hand side down, so we have x cubed minus 4x squared minus 9x plus 36, and that's equal to 0. So it's already equal to 0, so we simply need to factor that left-hand side before we can apply that zero product principle. The key here is that the expression on the left side has 4 terms. And in general, when we have 4 terms, we'll use factoring by grouping. So, to do that, we'll group that left side into 2 groups of 2. So the first one will be x cubed minus 4x squared, and we'll group that with parentheses. And then I'll change this to addition, and I'll add negative 9x plus 36. So negative 9x plus 36 is grouped in parentheses for my second pair there. Now, all I've done is apply that associative property to group these. From here, I want to factor out the greatest common factor from each of those pairs. So with x cubed minus 4x squared, I can factor out an x squared. So I'll have x squared times x minus 4. And then I'm adding, and this second pair that I have is negative 9x plus 36. So the greatest common factor that I can factor out from negative 9x and 36 is a 9. In general, I want to factor out the negative if there's a negative on that leading coefficient. So I'll factor out a negative 9, and I'll be left with x minus 4. So now I have x squared times the expression x minus 4 plus negative 9 times the expression x minus 4, and that's all equal to 0. I can note that these each have a factor of x minus 4, so continuing with factoring by grouping, I can now factor out x minus 4. So I'll have x minus 4 times x squared minus 9, and that's all equal to 0. I'm almost ready to apply the zero product principle at this point, but not quite. X squared minus 9 itself still has a squared term, and in fact is the difference of 2 squares. So I'll do one more step of factoring that x squared minus 9. So x minus 4 will stay as a factor, and x squared minus 9 as the difference of 2 squares factors into x minus 3 times x plus 3. So I now have the product of 3 factors set equal to 0. I have x minus 4 as a factor, x minus 3 as a factor, and x plus 3 as a factor. At this point, I'm ready to apply that zero product principle. So from here, this will break down into 3 equations. So I could have x minus 4 equal to 0, or x minus 3 could equal 0, or x plus 3 could equal 0. And again, because the product of all of those factors was originally 0, any of those factors themselves could have been 0 to give me a solution. So solving each of those equations, x minus 4 equals 0 solves down to x equals 4. X minus 3 equals 0 will give me x equals 3. And x plus 3 equals 0 will give x equals negative 3. At this point, I have 3 proposed solutions. So I'm going to check each of those solutions. I'll first check x equals 4. And in general, I want to check into the original equation to make sure that I haven't made any arithmetic errors along the way. So putting 4 in for x in that original equation, I'll be checking, does 4 cubed minus 4 times 4 squared minus 9 times 4 plus 36 equals 0. And so I'll put a question mark over that equal sign to see if it equals 0. Simplifying this, 4 cubed is 64, and I'm subtracting 4 times 4 squared, which is again 4 cubed, or minus 64. Then I'm subtracting 9 times 4, so I'm subtracting 36, and then I'm adding 36. So what I'm really checking here, I have 64 minus 36 plus 36, and 64 minus 64 will give me 0, and negative 36 plus 36 will give me 0. So indeed, 0 equals 0, and that checks. Checking the second one, I'm going to check the proposed, I have x equals 3, and so that proposed solution is 3. So I'm going to replace every instance of x with 3 and see if that makes the equation true. So I'll have 3 cubed minus 4 times 3 squared minus 9 times 3 plus 36. And I'm checking, does that equal 0? Going through and simplifying, this will become 27 And then minus 4 times 3 squared will be minus 4 times 9, which is minus 36, minus 9 times 3, which is minus 27, plus 36. So when that's simplified, I'm checking 27 minus 36 minus 27 plus 36, and I can see pretty quickly that indeed that left-hand side is also 0, so 0 equals 0. The last one I'll check is x equals negative 3. So I'm checking that proposed solution of negative 3. I'll do that by replacing every instance of x with a negative 3 into the original equation. So I will have negative 3 cubed minus 4 times the quantity negative 3 squared minus 9 times negative 3 plus 36. And I'm checking, does that equal 0? Simplifying the quantity negative 3 cubed, I get negative 27. Then I'm subtracting 4 times the quantity negative 3 squared. That negative 3 squared becomes positive 9, so I'm subtracting 4 times 9, or subtracting 36. Subtracting 9 times negative 3 becomes adding 27, and then finally I'm adding 36. So this simplifies down to negative 27 minus 36 plus 27 plus 36, and indeed that checks then, 0 equals 0. So now that I've checked all three solutions, I know that this equation has three solutions, and I can say then that the solution set is the set containing the number 4, 3, and negative 3. And again, I write that as a curly brace 4, comma 3, comma negative 3, and end it with a curly brace.